Hey guys, and welcome back to another video. Today we're going to be doing another LeetCode problem. So once again, I'm just going to read out the prompt, explain it, write out the code, explain the code, and then finish it off with time, complexity, and space. So what we have here today is a hard problem for the first time. And so LeetCode number 4, medium of two sorted arrays, given two sorted arrays, num1 and nums2, of size m and n, respectively. Return the medium of the two sorted array. The overall runtime complexity should be big O of log n plus n. And then here what we have is example 1. When we combine the nums1 and nums2, the arrays, it should come out to something like this. Then and then the median would be 2, right? Because it's in the middle. And then for something like this, where it's an even number, when we merge the array where it gets 1, 2, 3, 4, the median will be the middle between these two, 2 plus 3, and then divide that by 2, which is 2.5. Okay, so very easy. Now, what you sort of like need to know is that the problem gives you two arrays that are already sorted, right? And so the important idea is that like a simple way would just be to merge both arrays and find the middle. But if you were to do something like that, that kind of merging would just be m plus n, big O of m plus m. However, the prompt wants us to do log of m plus n, like that. So instead, what we should do is binary search, because with binary search, the idea is to split both arrays into a left half and a right half. And what we want would be that the left side is less than or equal to the right side. This means that every number on the left side should be smaller than or equal to every number on the right side. Okay? So right now I'm going to like I said, we're just going to make binary search, and I'm going to write out the code. Once I'm done writing, I'll explain everything. It'll take a little while because this is slightly more compared to like medium problems and easy problems. Okay, so if we're going to return a find medium, we're going to call it itself find medium arrays. We're going to have nums2 and nums1, like that. Once that's done, we're going to have integer m, and that's going to be the length of nums1. Integer n, and that's going to be the length of num2. We're going to have integer left, integer right, and then also integer for half. And the half will be m plus n plus 1, and divide that by 2. Now we're going to write a while loop. So while the left is less than or equal to the right, we're going to have integer I, and this I will be left plus right minus left. Divide by 2. Integer j, that's going to be half minus I. Integer nums1, and we're going to have it called nums1 left. Let's also write integer nums1 right. Okay. Now the left would be I, and that's going to be equal to 0. If it is, then the integer, we're going to grab the integer min value, or else, boom, boom, minus 1. Now for the right, this time it'll be m instead, and instead of the min value, we're going to have the max value. Again, same thing, and instead of 1 this time, it'll just be I. Now let's do integer for nums2 left and 2 right. And for this part, you kind of write the same thing, except it's j. Oops, then j minus 1. For the bottom part, same thing, j, but this time it's n instead of m. And we're doing the same thing, integer max value. And then just j. Now, still within the while loop, if the nums1 left is less than or equal to nums2 right, and nums2 left is less than or equal to nums1 right, and within that, n plus n, 2 equals 1, we're going to return math dot max of nums1 left, nums2 left, and we're just going to return math dot max nums1 left, nums2 left, plus math dot min nums1 right, nums2 right, and divide that whole thing by 2. Now if nums1 left is greater than nums2 right, then we're going to have right equals to I minus 1, else left equals to I plus 1, not minus. And then that should be it, and then we return everything by 0.0. Okay, that's a lot. That was a lot to write down, but let's run it to make sure everything is fine. Everything is not fine because I forgot to put an equal sign here. Okay, seems like our first case is wrong. Why is that? .5. Ah. I see the mistake. There we go. Perfect. Okay. All right, now that's done. Now I'm going to explain each line, and I'll show examples as well. Okay, so once again, this area, this part, this line, this function, it just takes in the two sort of integer arrays, and we're gonna have to return it as a double, right? And so, you know, sometimes again double because the medium can be a decimal, like for example the number 2. Okay, so what we have here, this part is we want nums1 to be the smaller array. Like I mentioned before, num1 should be the smaller array because we are doing a binary search on nums1, and binary searching in a smaller array is a lot faster. Okay, now these two, this is just to store the length of the both arrays. These are the binary search boundaries. So we are searching for the correct partition position in nums1, and then the partition can be from 0 to m. Okay, so for example, in case you don't understand what I meant, is let's say that nums1 has, again, like the array 1 and 3, right? So then the possible sort of, like, you can call it cuts, would look something like this. Something like that. Okay, so just showing you the example. I'm going to remove it real quick. Now right here, this tells us how many numbers should be on the left side. Okay, and then the +1 helps if the total length is odd. So again, example, let's say that our total length is 3, right? So the half will be a 3 plus 1 divided by 2, and that's going to give us 2. Okay, so the left side gets 2 numbers, and then the right side gets 1 number. So again, like I said, if we take an example from this one, I should probably write it like this. Sorry. There we go. See how the left side right here, or sorry, the yeah. So our length for m is the nums1, which is 2, and now our length for the n, which is on the right side, which is 1. So 2 plus 1 plus another 1 is going to be 4. 4 divided by 2 equals 2. And so the left side gets 2 number, the right side gets 1 number. That makes it easy to return like the largest number on the left side as the medium. Okay, let's remove that real quick. Now here, what we have, this while loop is going to keep binary searching until we find the correct partition. Right here, I is the partition's position in nums1. So what we have here is, the left plus the right minus the left. Yeah, pretty simple. So like I said, it just means that how many elements from nums1 go to the right side. Go to the left side. Sorry, left side. Now here, J is the partition position in nums2. Okay, so if the left side needs half total elements, and we already took I from nums1, then we need half minus I from nums2. Now right here, Now right here, this line, this basically means that as this gets the biggest number on the left side of nums1, right? So if I is equal to 0, that means we took nothing from nums1 for the left side. So we have to use integer min value as a fake very small number. Okay, and then this right here, same idea. This gets the smallest number on the right side of nums1. So if I is equal to m, that means everything in nums1 is on the left side. Okay? So again, if there's nothing on the right side, then we use the integer max value. And again, it's a fake very large number. These two, it's the same idea, but you're doing it for nums2. And so we only care about the 4 boundary values, right? Which is nums1 left, nums1 right, and then nums2 left, and nums2 right. Okay, so only these 4 values are what we care about right now. Now here, this checks if the partition is correct. And so again, like I mentioned way before I start writing the code, what we need is the left side being less than or equal to the right side. Okay, so again, if we want to be very specific, I basically wrote it down. We want the left of 1 to be less than or equal to the nums2 right. And then for the nums2 left, we want that to be less than or equal to the nums1 right. So if both are true, then we found the correct split. Where were we? Oh yeah, right here. So this part is, again, if the total length is odd, then the medium is the largest value on the left side. Now, why? It's because we purposely have to make the left side hold 1 extra element. Okay, and then this part, if the total length is even, then the medium is the average of the largest number on the left side, and the smallest number on the right side. So what we would do would be exactly find, like I said right here. Okay, I'll just write it down. What we would do would just be the max left plus the minimum right, and then we do that by dividing 2.0. Okay, now again, the 2.0 makes the answer like a decimal. And you can kind of see right here. See, look, the math max for the left on these, and then the math min for these. Now, this part right here specifically, if nums1 left is too large, that means we took too many elements from nums1, right? So we have to move the partition left. And this one, it just means that if we did not take enough elements from nums1, we have to move the partition to the right. Okay, which is why there's a -1 and there's a +1. And then, you know, finally this part, this line is only here because Java requires a return. So for a valid like sort of input, we should find the answer within the loop. Now, hopefully with what I explained makes sense, but if it doesn't, don't worry, because I'll give like a walkthrough example, and we're gonna use example 1 to do it. So looking at example 1, nums1 and nums2, we can, since nums1 is longer than nums2, the code will basically swap them, okay? Because look, right here, this part, if nums1 length is greater than nums2 length, we're gonna swap them with nums2 this time being at the front, and then nums1 being at the back, right? So like this. And, oh, sorry. It'll look something like this. Like that. We basically switch these two arrays, okay? And so now what we have is we're gonna have integer m and n, which m will be 1 and n will be 2. And then now again we're gonna do the calculation for the half, which will be 1 plus 2 plus 1 divided by 2, and that's gonna give us 2, right? And now we're gonna do our first binary attempts. So maybe I'll do it in here. I don't know if it looks bad, but actually, let's do it out here. So our left is gonna be 0, and our right is gonna be m. M is 1 right here. So, oops, 1. Yeah, there we go. Our I is gonna be left plus right minus left divided by 2, and you know, so I will be, let's just do it, 0 plus right being 1 minus 0 divided by 2, and that's going to just give us 0, okay? Because again, I'm not doing the decimal, I'm just doing divided by 2. Okay, and then the j will be the half being, what was the half again? Oh yeah, half right there. 2 minus 0, oops, not 9, and that's going to give us 2. Okay, so what we have here is that j is 2, and then the I is 0, like that. Okay, now that we have the numbers, the partition would look something like this. Like that. Okay, so again, the left side will be 1 and 3, and then the right side would be 2. Now, we look at our boundary values. Remember what I meant? Remember what I said? It's these 4. And so it should be very easy. Our nums1 left will get the integer value of the minimum. We'll get the integer minimum value. And our nums1 right will have 2. Now nums2 left will be 3, and then nums2 right will be the integer maximum value. Like that. Okay? And so, again, like just by looking at it, because I already wrote down the I and the j, the I being 0, so what we have here is this. We grab the minimum value, and then for the I right, I being 0 and equal to m. So if that's not true, then we don't grab the maximum value, we just grab the I inside the nums1. Okay? And that's very simple, very simple. Okay, now, so now we're gonna check. Oh, where were we? Oh yeah, right here. Now we check that the nums1 left is less than or equal to nums2 right. So we check that, and this is true. However, our nums2, oh, I should probably move this down a little bit, right? Because I'm doing it right here now. Oops. Whatever. Look right here. However, okay, so this part is true. However, this part is not true. So our nums2 left, nums1 right. It's not true because, 3 is not less than or equal to 2, right? So since this part is false, it means that the partition is wrong. It means that our nums2 left, which is the 3, is too big. And what we need, and this kind of just means that we need more from nums1 on the left. So now what it does is going to do the code for, it's going to do this part right here. Okay, so left I plus 1, so I being what, 0, right? Yep. It'll just be left equals to 0 plus 1, which just means 1. Like that. And now, so that means our first binary search attempt was a fail. Now we're going to do a second one. And before that, I'm going to remove this because I don't want to accidentally run the code and it's going to show more error. And we're going to remove all, just these. And then update this part. Now our left becomes 1 because remember right here, we already did the 0 plus 1. Okay, so now the left is 1, the right is 1. Our I is also going to be 1. And then our right will stay as a 1, okay? Our I is 1, and then our J, I think our J needs to be updated as well because half will be 2, 2 minus I being 1, and it's going to give us 1 as well. Now our partition should look something like this. 2, and then nums2 will have a 1 and 3, like that. So if you just look at it, our left side now will look something like this. And our right side will just be 3. Now we continue with our 4 boundary values. I'm going to do it down here real quick. Like that. So our nums1 left will be 2. Our nums1 right will be the integer of the max value. Our nums2 left will be 1. Nums2 right will be 3. Okay, now we would check nums1 left is less than or equal to nums2 right. And now this basically shows that the 2 is less than or equal to 3, and that is true. And now our nums2 left is less than or equal to nums1 right. And that part is also true because 1 is definitely less than or equal to the integer's maximum value or max value. And so since that's also true, now we have found the correct partition, and the total length will be m plus n, and that's going to be equal to 3. Okay, and since 3 is an odd number, we're going to return the math dot max of nums1 left and nums2 left. All right, so for that part, that's going to be basically math.max of 2 and 1, and that's just going to be 2. And so the final answer will be 2.0. I'm just going to remove this because this is too much. Remove this part as well, and then remove all of these. Let's run it again just to make sure. Oh my days. Okay, let's run it again. Okay, now with this, since it's complete, I'm gonna just submit it just to show you. Now our time and space complexity, which I will also explain, our time complexity will be exactly how they want it, which is big O of log, and if you want to be really specific, it would just be log of the minimum n and n, m and n. and this satisfies what they wanted. And now the space complexity will actually just be big O of 1. Here's the thing. We did not create like a merge array. We only use variable. It looks a lot, yes, but what we only use like variables, like left, right, ij, the nums left, right, and so the space is constant, which is just big O of 1. And you need to think about it, that the main trick is, instead of merging both arrays, we just use binary search to find the correct split where everything on the left side is less than or equal to everything on the right side. And that's how I get them. Let me submit it one more time, just to make sure. Okay, so everything seems good. All right, yeah, so that's basically it. It is a hard problem. It takes a while to think about it. Technically it should be easy, but what they want is that the overall runtime complexity to be log of n plus n. So, yeah. Thanks for watching.